Hey guys, go ahead and get your math notebook. And we have finished up topic 13. Guys, do you know we only have topic 14, 15, and 16 left for your 5th grade math. 3 topics left, that's it. And you guys are gonna be doing middle school math then. You guys are fine, you're ready, you're prepared. Before we start topic 14 though, I wanna have some math fun. So we're gonna have today, we're not starting a new topic today, we're just gonna have some math fun with some numbers, okay? So of course I have some tricks lined up for you guys. I have a TED Talk lined up for you guys, probably an Estimastory if we get some time, all right? And let's just have some fun. All right, here we go. This is from from Friday, so you can ignore. Not too much fun? Is there such a thing as too much fun?
Yes.
All right, here we go. Ladies and gentlemen, good computation here is going to be key. I want you to think of a 3-digit number. 3-digit number. Anything you want. I'm going to go with 212 is my 3-digit number. 1, 2, 3. You pick your own 3-digit number. Everybody's done this. Mouths are closed. Watching up here to be a listener. Everybody's got their 3-digit number?
Yeah.
All right, I want you to arrange those numbers in descending order. What does that mean, descending order? Max? Yeah, biggest to smallest in descending order. So my numbers in descending order are going to be this now. So put them in order from biggest to smallest. So I have 2 are the same, so it doesn't matter which one goes first. Descending means biggest to smallest. All right, next step. Everybody's good? Next step is to reverse that order. So this order I have 2, 2, 1, reverse it. So now I'm going to do 1, 2, 2.
So like least to greatest?
Not least to greatest, you're just flipping it. So I have 2, 2, 1, reverse it. So this number is first, this number would be second, this number would be third.
My number just went to the same number as the first.
I'm going to give you guys one more example. I know some of you guys are slightly confused because I have 2 digits that are the same. So I'm going to do 2 at one time. I'm going to do 465 also. Okay? When I put that in order, descending order, I'm going to get 6, 5, and 4. And then I'm going to flip that. So when I flip that, reverse the order. 4, 5, 6 is what we've got so far. So I've got 2 happening at one time here. All right, so we all have different numbers right now, right? Bradley, what do you have? What's your last number that you wrote down?
367.
367. Charlie? 235. Alyssa? 123. Mimi?
023.
023. Malia?
135.
135. Justice? 025.
237.
237.
127.
127. 235.
119.
119.
123.
123.
235.
235.
Yeah.
732. So lots of different numbers, okay? Our next step is to subtract. So you're going to take these 2 numbers right here and subtract. Okay, subtract. So I've got to borrow on mine. Everybody's working on their subtraction, right? Alright, so I've got two examples here. I've got two different numbers. I've got 99 and 198 now. Alright, next up, you're going to reverse the order. So whatever this bottom number is, reverse it. So, I've got, on this one I'm going to have 990. On this one I'm going to have 891. Alright? So all you did was reverse your number that you got. Now you're going to add the two numbers together. So these two numbers right here, let's add them. So I've got 99 and 990. I'm going to add these two. Ladies and gentlemen,
How did you? Wait. What?
did you get 1,089?
Yes.
If you did your math correctly, you got 1,089.
This is mathematically.
Is that not crazy? We all started with different numbers. How, when we went through that whole thing, would we all get then 1,089? What YouTube channel? My own. This is my own YouTube channel. I make my own. You guys better start subscribing to my YouTube channel before I'm just so famous.
Do you get a math board in there?
I'm gonna be a billionaire with my math YouTube channel, guys. All right. Let's do a shorter one. Ready? I want you to think of a 3-digit number. Hold on. Specific rule here, where all the digits are the same. Example, 333, 777, 999. You guys know my favorite number is 2, so I'm going with 222. Now, we might have some friends in the class who choose the same one because there's only so many 3-digit numbers where we use all the same 3 digits. Okay? So have your number written down. I want you to add up the digits. So for me, I get 2 plus 2 plus 2. I got 6. All right, I want you to take this number when you added up your digits, and I want you to divide. Oh, so we're going to do 222 divided by 6 for me, for my example. You go ahead and do yours now. Yes. No, like, Mimi, take your little iPad to the middle school office. Alright, so when we do this dividing, everybody needs to do theirs. I get, I'm going to use different color. Ready? What's 22 minus 18? 42 divided by 6. Everybody got 37. Everybody got 37, if you did your math correctly, guys. All right, last one. I want you to write down, this was kind of like a math fact. Not so much a trick, I guess. More of just an interesting idea about our math facts. We're going to do 6 times an even number. When you do 6 times an even number, the final digit and the answer will always be the same. So like this. What is 6 times 2?
12. I got 72.
So look at this final digit is always the same as this one. Your first digit is always half of the second. So watch us do another one. Find 6 by an even digit only. So 6 times 4. What is 6 times 4? 24. Your last digit, look it, is always the same of what you multiplied by. Your digit in the ones place is always half as much. Half of 4 is 2. Let's do another one. 6 times 8. What's 6 times 8? 48. Look at my 8. My tens place is always the same as what I multiplied by. My ones place is half as much. What's half of 8 is? 4. Pretty cool? 6 times any even number will always be that.
Isn't 8 the ones place?
So let's do you guys need to do any more? You guys see that pattern?
Yeah.
Interesting? All right. All right, let's watch. I like cartoon movies.
Yeah.
I have young kids, so they watch lots of cartoon movies. One of them they watched over the weekend was Alice in Wonderland. And that queen, what does the queen always say in Alice in Wonderland? Off with their heads, yeah. So I have some math fun with Alice, where Alice had an encounter with the evil queen, and she has a math mystery that she needs to solve. So you're going to need your math notebook because I do want you guys trying to solve this one. I will play it more than one time because I know it's hard to catch some things. So the first time you watch it, do not take any notes, have pencils down, and just watch it. The second time you watch it, I want you to go ahead and take notes, okay? So first time through, we're just going to watch. All right, here we go. Let me make sure I got some Valium. It might be loud. I'll turn it down if it is. It's okay. No, it's not that loud.
After many adventures in Wonderland, Alice has once again found herself in the court of the temperamental Queen of Hearts. She's about to pass through the garden undetected when she overhears the king and queen arguing. It's quite simple, says the queen. 64 is the same as 65, and that's that. Without thinking, Alice interjects. Nonsense, she says. If 64 were the same as 65, then it would be 65 and not 64 at all. What? How dare you, the queen huffs. I'll prove it right now, and then it's off with your head. Before she can protest, Alice is dragged toward a field with 2 chessboard patterns, an 8x8 square and a 5x13 rectangle. As the queen claps her hands, 4 odd-looking soldiers approach and lie down next to each other, covering the first chessboard. Alice sees that two of them are trapezoids with non-diagonal sides measuring 5 by 5 by 3, while the other two are long triangles with non-diagonal sides measuring 8 by 3. See, this is 64. The queen claps her hands again. The card soldiers get up, rearrange themselves, and lie down atop the second chessboard, and that is 65. Alice gasps. She's certain the soldiers didn't change size or shape moving from one board to the other, but it's a mathematical certainty that the queen must be cheating somehow. Can Alice wrap her head around what's wrong before she loses it?
Alright.
That's awesome. No. Don't pause it.
Alright, ladies and gentlemen, I'm going to go ahead and play it one more time. This time, as you are watching it, I want you to be taking notes that are going to help you solve this Alice in Wonderland riddle. Before I rewind it, look at the notes they have up here. They have your two grids, one being 64, one being 65. Here are the four pieces that they are using. And it says, number one, the same four soldiers seem to cover areas of 64 and 65 squares. You must explain where the extra square came from. The only things that change about the soldiers from one grid to the next are their positions and orientations. All right, I'm going to replay it. Pencils ready, taking notes?
Cheating somehow.
Thank you, yes.
After many adventures in Wonderland, Alice has once again found herself in the court of the temperamental Queen of Hearts. She's about to pass through the garden undetected when she overhears the king and queen arguing. It's quite simple, says the queen. 64 is the same as 65, and that's that. Without thinking, Alice...
Alright, so she's saying that 64 and 65 are the same, meaning like those values are the same. So those grids, one grid has 64 little squares, one grid has 65 little squares, and she's saying that they are the same. Do you guys think in your math brain, can that be the same?
No.
Okay, but those pieces, they seem to cover the grid with 64 and the grid with 65. You need to be able to explain, how is that? If they're not the same, shouldn't one of them not be covered all the way? All right, no answers yet, no questions yet. That's what you are solving.
Interjects. Nonsense, she says. If 64 were the same as 65, then it would be 65 and not 64 at all. What? How dare you, the queen huffs. I'll prove it right now, and then it's off with your head. Before she can protest, Alice is dragged toward a field with two chessboard patterns, an 8 by 8 square and a 5 by 13 rectangle. As the queen claps her hands, four odd-looking soldiers approach and lie down next to each other, covering the first chessboard. Alice sees that two of them are trapezoids with non-diagonal sides measuring 5 by 5 by 3, while the other two are long triangles with non-diagonal sides measuring 8 by 3. See, this is 64. The queen claps her hands again. The card soldiers get up, rearrange themselves, and lie down atop the second chessboard, and that is 65. Alice gasps. She's certain the soldiers didn't change size or shape moving from one board to the other, but it's a mathematical certainty that the queen must be cheating somehow. Can Alice wrap her head around what's wrong before she loses it?
Alright, ladies and gentlemen, I'm going to pause there, and I'm going to give you guys some work time to solve this math riddle so Alice is knocked off with her head. Help Alice out to explain this to the queen. I'm going to give you guys a couple minutes, and then we'll talk about it. Malia, lights, please. Ladies and gentlemen, give me some math explanations and tell me how is 64, this grid of 64, and this grid of 65, how can they not be the same? How is Alice going to explain this to the queen?
Because I know that she's cheating because if you put these two shapes together, they will equal the size of the rectangle chessboard. And then the other two are just overlapping.
So you're saying some of the cards are overlapping is how she's cheating?
Like something like Mason said, you can't really put the two shapes in one of those squares because it'd be overlapping.
So because of the shapes, you're saying those two make a rectangle?
Like, yeah.
So they would be overlapping then, Max?
I think it's like geometry. Since they have like weird angles and weird sides, they can be put together and make those become around.
So you think it is true then?
Um,
Like it is possible that those cover both?
yeah, but they have to be put in certain ways.
Okay, so I'd like to use the math word geometry. That's going to be one of our 3 topics that we have left that we're coming up to. So he's saying because of geometry and how these pieces can be arranged, you could arrange them that yes, it does cover both grids. What else? Malia.
I think this is similar thing, but when sometimes with the other cards, they have them facing that way or they'll flip them around.
So like these cards, they can flip them around
Yeah.
to be able to fit. Okay, what else? Come on. Huh? You forgot yours? Demi?
I want to like change my answer is like something like accident they could maybe go on them, but they can't like if you wanted them to like fit perfectly, it like you'd have to arrange it in a certain way.
So you guys are saying it is possible that 64 and 65 are the same because of how you can arrange those 4 pieces?
No.
Bradley?
So if you two like sharp ones,
Uh-huh.
if you switch one,
These 2?
yeah.
Okay.
If you flip that one the other way, it'll make a tiny rectangle,
So if you flip one of these and you put them together, it makes a rectangle.
a little, and that will go half, and then you do the same with the other ones. And it goes.
So also this one you can flip and they make a rectangle together. Okay. Aiden?
I think so the 2 wide ones you flip them so the 3 is where the 5 is and then
So you're flipping them so they fit together.
no so it's making like a ramp going down.
Okay.
One going back up. You put those the 2 skinny ones in between them.
Oh, so you're saying you could put these 2 in between them then?
Yeah.
Okay. All right, ladies and gentlemen, let's watch and find out. Lights, please.
Have any of us got it right?
Hold on, let me get my volume.
I think you're
Just as things aren't looking too good for Alice, she remembers her geometry and looks again
Geometry,
at the
math
trapezoid and triangle soldier lying next to each other. They look like they cover exactly half of the rectangle, their edges forming one long line running from corner to corner. If that's true, then the slopes of their diagonal sides should be the same. But when she calculates these slopes using the tried and true formula rise over run, a most curious thing happens. The trapezoid soldier's diagonal side goes up 2 and over 5, giving it a slope of 2/5 or 0.4. The triangle soldier's diagonal, however, goes up 3 and over 8, making its slope 3/8 or 0.375. They're not the same at all. Before the queen's guards can stop her, Alice drinks a bit of her shrinking potion to go in for a closer look. Sure enough, there's a minuscule gap between the triangles and trapezoids, forming a parallelogram that stretches the entire length of the board and accounts for the missing square. There's something even more curious about these numbers. They're all part of the Fibonacci series, where each number is the sum of the two preceding ones. Fibonacci numbers have two properties that factor in here. First, squaring a Fibonacci number gives you a value that's one more or one less than the product of the Fibonacci numbers on either side of it. In other words, 8 squared is 1 less than 5 times 13, while 5 squared is 1 more than 3 times 8. And second, the ratio between successive Fibonacci numbers is quite similar. So similar, in fact, that it eventually converges on the golden ratio. That's what allows devious royals to construct slopes that look deceptively similar. In fact, the Queen of Hearts could cobble together an analogous conundrum out of any 4 consecutive Fibonacci numbers. The higher they go, the more it seems like the impossible is true. But in the words of Lewis Carroll,
But look
author
at there
of
was
Alice
that
in
very
Wonderland,
slim
and
gap
an
that went
accomplished
between.
mathematician who studied this very puzzle, one can't believe impossible things.
So Alice is saying,
No, she just fell down a hole.
maybe it's this Wordle.
And then she falls into it.
All right. Ladies and gentlemen, we're going to do
Mystery.
Oh, yeah, the mystery. I'm confused how that made any sense. Yes, it's
let me see what number we're on.
58.
21.
Number 7.
Oh gosh.
Hold on.
Okay, I gotta see this.
Are you ready?
All right, ladies and gentlemen, we're going to play a mystery called the Dice Jam. So this is number 7 in your math notebook. And we have a vase that is full of these dice. I'm going to zoom in for you guys to see. Full of these dice. All right? I want you to go ahead and make an estimate of how many dice are in this vase. You can stand up if you need to. How many dice are in this vase? Everybody write down a number now. How many dice? How many dice? How many dice? All right, here we go. Clue number 1. Only one of the 2 digits from the answer can be seen on the face of a die. So your answer has to be a 2-digit number, is what they're telling you. So anything that has a 3-digit or higher number is too big. And only one of the 2 digits from the answer can be seen on the face of a die. So you need to see the face of a die. You need to see all the numbers that you can see here. Okay? If clue 1 does not fit your estimated number, you need to make a new estimated number. Clue number 2. The answer is an odd number. So if you have a new even number, you need to make a new one. Mason, put that down, please. Clue number 3. Look at the yellow die. I see the yellow die right here. And I see a 6 a 3, and a 5. A 6, a 3, and a 5 on this yellow die right here. And it says none of those numbers is a digit in the answer. A 6, a 3, and a 5. If you have one of those, you need to make a new estimate. Everybody good?
I'm scared.
All right, clue number 4. Find the red die with 2 visible faces. I would say that's this die right here because I can see 2 of them. And I see a 5 and a 4. Okay? Yes, there are other red die, but I can't see 2 faces. So a 5 and a 4 in this red die. Find the sum of those 2 faces. So 5 plus 4.
9.
That sum is not a digit found in the answer. So no 9s. If you need to, make a new estimated number. All right, ladies and gentlemen, lights on, please. Give me some estimates that fit the clues, or so you think they fit the clues. And let's check. Raina?
47.
Bradley?
55.
Kara?
27.
Mason?
27.
We got 27 feet down, please, off my desk. Alyssa? 21. Mimi?
24.
Even number. Can it be 24?
Oh, no.
Has to be an odd number. Do all these other ones follow our rules?
Yes.
Let's see here. All right, here we go. The number of die. Lights, please. Lights, camera, action. All right, by combining the clues and estimation, you now have enough information to determine the answer. And the answer is 47 dice. That is way higher than what I would have guessed. I would not have guessed 47 dice right there.
That is impossible.
Does not look. I wouldn't have guessed. Honestly, I wouldn't have guessed probably anything over 30. But shockingly, it is 47. All right, guys.